The advanced day, night, and seasonal sky system is a powerful, complete environmental solution for Unity. It delivers full time-of-day control, seasonal blending, sun and moon motion, and advanced environmental lighting. This technically robust and artist-friendly system is compatible with the built-in render pipeline and universal render pipeline, enabling you to realize highly stylized or realistic creative visions without writing complex custom code. Let's dive right in. If your project is using the universal render pipeline, make sure you have the URP package installed and set up before you begin. Open the included demo scene. For integration into an existing project, just drag and drop the Day-Night Seasons controller prefab. The prefab has been modified in the demo scene for this demonstration. Next, open the Sky Visualizer from Window, Day-Night Cycle, Sky Visualizer, or select the DNS controller game object in the hierarchy and use the button at the bottom of the inspector. The Sky Visualizer is an editor-only tool that provides a 360-degree preview of the entire sky. The preview updates in real time as time changes in the game. You can also toggle gizmos to display helpful markings like the sun and moon paths. Press play and watch the sunset. With the DNS controller game object selected, lock its inspector view with the small padlock here. Now, expand the time foldout and change the start time of day to preview the environment. This immediately applies the environmental conditions at the start time of day based on the assigned profile under the seasonal system foldout, the configured days per year, and the current day of year. Adjust the current day of year slider and you will see how the environment changes at the start time of day throughout the year. Set the start time of day to 12 and the current day to 1. In this 4-season profile, day 1 is spring. Now set the current day of year to 100. This represents the height of summer, as you can see in the visualizer by the sun's position in the sky. Now try day 200 for fall, and finally, day 300 for winter. Day 400 takes us back to day 1. Now set the start time of day to 6, and the speed to 100 and press play. As you adjust the current day of year, you will see the sun's path change as it moves across the sky during the different seasons. You have full control over these paths within the seasonal profiles, which we'll see later in the video. Let's test some of the included seasonal profiles to see the range of possibilities. Open the presets folder and assign the 4 Seasons Alien preset to the seasonal profile field. Set the time to 17, which is 5 p.m, and adjust the current day of the year to scroll through the seasonal environments. This is a more extreme seasonal profile. Now assign the 2-season Cyberpunk profile. As this is a 2-season profile with 400 days in the year, Season 1 is 100% at day 1, and Season 2 is 100% at day 200. A 50% blend of the 2 seasons occurs at day 100 and day 300. If we test these values side by side, you will see that the environment remains the same, demonstrating how the system blends between adjacent seasons in a cyclical manner. To demonstrate fog control, navigate to the Unity lighting settings under Window, Rendering, Lighting, and select the Environment tab. Enable the fog checkbox under Other Settings. Now navigate back to the Day-Night Cycle component and ensure fog control is enabled. Now try setting different times of the year again. Since the seasonal profile contains fog parameters, the Day-Night Cycle applies these settings to Unity's render settings. Feel free to explore all 21 presets. You can use them as they are, but I encourage you to use them as templates to create your own looks. We will look at how to do that later in the video. For the next section, let's assign the 4 Seasons stylized profile at just before sunset. So I'll use a value of around 17.75. Let's now examine the inspector controls beginning at the top. To control the speed of the day-night cycle, navigate to the time section, set game minutes per second to control how fast time advances in-game. For instance, As you can see in the tooltip, a setting of 60 is equivalent to 1 in-game hour per real-world second, or 24 real-world seconds is equivalent to 1 in-game day. Let's set it to 10 for now and set the time of day to 12 p.m. The reset system allows you to smoothly move to a new time value using 2 different modes. Time-based completes the transition in a fixed amount of time, regardless of how much time it needs to cover to reach the target. If you've opened a new project, click on the event system and add default input modules so you can interact with the UI. With current time set to 12, when I fast forward or rewind time, it always takes the same amount of time to reach the target. Now change the drop-down to speed-based and increase the speed to 5. This completes the transition at a consistent speed, regardless of how much time it needs to cover to reach the target. Starting at 12 p.m, it moves at the same speed to 3 p.m, 9 p.m, and midnight. We also have some extra controls available. Let's set it back to time-based and use a speed of 1. Use the dynamic reset buttons to reset to a given time along the shortest path, forwards or backwards. For example, if the current time is after 12 p.m. and I dynamically reset to 12, time will reset backwards. If current time is before 12, the time will reset forwards. Instant reset instantly sets the time and related environmental conditions. Let's adjust the current time of day for a different look. Under Sun and Scene, you assign the primary directional light as the sunlight. The rotation pivot is the transform that the system rotates to move the sun across the sky. The east-west rotation property provides a yaw offset applied to the sun's path, which is useful for aligning sunrise and sunset with your environment's art direction. You can preview this in the Sky Visualizer. The sun always rises in the east and sets in the west. Assign your main camera here, as it is used for features like preventing parallax for celestial objects. We'll come to that a bit later. The Skybox section controls which sky system is active. The system supports 4 modes. Procedural uses Unity's built-in procedural skybox, and this is what we've been using up to now and will for most of this video. Single cube map uses a fixed cube map with an optional rotation. Note that the sun disk is not supported in Unity's built-in cube map material. Cube map blend blends between day and night cube maps, with optional seasonal blending too. The cube maps are defined in the seasonal profile, and this mode only works with cube maps assigned. The provided cube map blend material is used here. And custom material allows you to use your own Skybox material and shader. For custom material mode, the system can drive properties like blend and exposure on your material. The provided shader here is just an example and not something you would use in your game. The seasonal system drives environmental conditions. As we have already seen, it includes the days per year and number of in-game days per full seasonal loop, as well as the seasonal profile, which is an asset containing all seasonal settings like lighting, exposure, tint, fog, and day-night windows. The Live Update Profile checkbox enables you to see changes to profiles in real time. Let's remember that for later. The Celestial Bodies section controls the star and moon systems. Let's enable the moon pivot game object in the hierarchy, then toggle the moon on using the moon checkbox. Now in the scene view, we can see the moon's path along this white circle. If you can't see the moon in the Sky Visualizer, make sure the moon is up in the sky somewhere and at nighttime, and make sure the moon is on the culling layer used by the visualizer, or set the visualizer to show everything. The moon system simulates both orbital motion and lunar phases. You can define the moon orbital days for a complete orbit and lunar phase days for a full phase cycle. If we change the current day of year, we can see how the moon's position changes. The Celestial Bodies container allows you to prevent parallax for stars and other distant objects when no parallax is enabled. With no parallax enabled, the moon doesn't follow as we move around, making it look very distant. If I disable the parallax checkbox and move around, you will see we can fly right up to the moon, making it appear very close. We can customize the moon's appearance in the material. Properties controlled by the seasonal profile cannot be changed here, but you can simply duplicate the moon and adjust the values on the copy, which gives you full control. The minimum alpha sliders affect transparency, which can help the moon to really blend into the sky in a realistic way, while blocking stars. But if the moon is visible during the day and produces an eclipse, you will see the sun through the moon because the sun disk is actually part of the sky. You can disable the moon's visibility during the day in the seasonal profile, which we'll see in the next section. Fog control allows the day-night cycle to apply fog settings from the seasonal profile to Unity's render settings. Remember that fog must also be enabled in Unity's render settings to use this feature. The water section allows you to assign a water renderer whose material will be tinted over time. And the UI section allows you to define text to show current time and day of year. Both legacy text and TextMesh Pro objects are supported. I have included two scripts to demonstrate how the system can be extended. First, let's look at the orbital controller. Let's disable fog so we can see things clearly. Enable the orbital objects game object in the hierarchy and disable the moon in the hierarchy and inspector. We have two orbiting objects. Let's start with the famous thing from a popular franchise. Select it in the hierarchy and you will see it has the orbital object script assigned. The orbital object component allows any game object to orbit a pivot based on the day-night cycle time. As you adjust the orbital pivot, orbital period in days, and the orbital radius, you will see the path reflected in the scene view. Advanced settings allow for elliptical orbits via eccentricity and a no parallax option. Now let's select the satellite in the hierarchy. You will notice it has the orbital object as well as the satellite example. This additional script allows you to control extra features like lights and sound effects. You can easily create these extension scripts to fit the needs of your project. Finally, let's enable the lights game object in the hierarchy and press F to focus on the objects. The lighting controller component automatically controls scene lights and emissive materials based on the time of day. You can define a time window for when lights and emissives are active using light on off time or emissives on off time. It supports randomized features like flicker count and randomness for turn on off delays and allows for gradient-based color assignment for variations. Now let's get into the seasonal profiles, as these are key to creating the environment and look you want for your game. For a new clean profile, right-click in the project window and go to Create, Day-Night Cycle, Seasonal Profile and give it a name. Now assign this new profile to the Day-Night Cycle component like before. I'm going to disable the orbital objects and the gizmos in the sky visualizer so I can see clearly what's happening. Start by collapsing all the foldouts. You will see there are global settings at the top, followed by sections for 4 seasons. Use the checkboxes next to season names to enable and disable them. Let's just start with Season 1 for now, which is always active. Let's now enable the Live Update Profile checkbox. This will apply changes to the scene as we make them, which makes development quick and easy. Instead of starting from scratch, let's copy a season from another profile. Select the profile you want to mimic and click Copy All in the inspector. Navigate back to the new profile, lock the inspector, and click Paste All in Season 1. Now let's start creating a custom profile. Ambient color controls the general lighting on objects, while sun color affects the sun disk. Background color is a camera property. You will only see this if you set the skybox mode to custom and remove the material from the input field. However, let's stick with the procedural skybox for now. Sun intensity and shadow strength are standard controls. The sun convergence helps you fine-tune the sun's size, and the sun exposure affects the brightness of the sky without changing the lighting on your assets. The skybox tint allows you to colorize the atmosphere for artistic effect. Next, you can control the fog. Remember to enable it in your lighting settings first, and the color of the water if you have a compatible shader. You can also adjust the moon color and brightness here. Finally, let's look at the fine-tuning options. To visualize this, disable fine-tuning for the stars. If you play the particle system by clicking on it in the hierarchy and pressing play here, then adjust the time of day and scrub around the sunrise or sunset, you will see the stars that are visible during daylight. Now, enable fine-tuning for the stars and adjust the time again. The stars will fade in and out naturally at sunset and sunrise. You can adjust the duration of this blend at the bottom of the profile. The same logic applies to the shadows and the moon. The day-night lighting windows feature handles this blending for lighting and shadows, ensuring that the sunset lighting doesn't bleed into your night scene. Be careful when adjusting the day-night lighting window, because if it's too tight, you might get strange behavior like the sun suddenly becomes very small just as it moves beyond the horizon. Once that's done, repeat the process for midday, sunset, and night. Remember to set the start time of day to match the time frame you're working on. For example, set to 12 for midday or 6 p.m. for sunset. Finally, you can add up to 3 more seasons in the profile. It's entirely up to you, but as you work through these, just remember to change the current day in the year to match the season you're working on. If you want to revert changes to a profile preset, you can recreate all the built-in profiles in the right-click menu, and if there are particular properties you want to change for all the profiles, like the lighting windows, you can use the provided Python script. Instructions are included at the top of the script. For developers, a clean public API is provided to the control system at runtime with functions like set to custom time instant to jump immediately to a specific hour, set time speed, and pause time, resume time. Common API is provided in the documentation, but you can also look at the scripts to find the complete list. Thank you for watching.